So really the cosine law works when the sine law fails, and the sine law requires an angle and the side opposite. Got to have that. So two angles and any side. Actually, that's not true, because if you know two angles in a triangle, you would know all three angles, because you just have to subtract from 180 to get that missing angle. It's an extremely quick step there. And then you would automatically have an angle side pair no matter what side they gave you. Two sides and any angle, ooh, that is hinting at a cosine problem here, because if I've got two sides and the angle in between, then I don't have that angle side pair, and that would be a cosine law. But any angle, well, if I've got two sides, wow, I don't know why it's so funky there. If I've got two sides, and let's say I've got these two sides, but I have this angle right there, well, then I do have an angle side pair, so it's not that one. All of the sides, oh, yes. That one right there would be the cosine law. Now, watch what happens with D. All of the angles. That actually doesn't work as a cosine law. Having all the angles doesn't give me that angle side pair that I need for the sine law. So you might think, okay, well, if that doesn't work, then maybe that is the cosine law. But the problem is, when you've got all the angles, that creates an interesting sort of a situation here where, like these two triangles right here, the angles are all the same, but the size is different. So the sides are different. Having all of the angles doesn't actually help you out here. We have no idea how big the triangle is, so we really can't use the sine law or the cosine law in that case. There's really a lack of information here. So yes, if you've got all three sides, I can draw a triangle. I can use the cosine law.